Hi there, welcome to this course on the very cool and exciting topic, building real-time web applications in Node.js. Take a moment if you would and think back to your first memorable experience with a real-time web application. The first thing that comes to mind to me is Trello, a simple project collaboration tool that I suspect many of you are familiar with. It's such a great example of a simple application that solves real problems with just the right amount of real-time features. I remember thinking at the time, this is so cool. I must build real-time applications. I'm sure a lot of you have had similar feelings at one point or another. So, here's my question for you. Are you routinely considering real-time features when developing web applications? Don't feel bad if your answer is no. You're in the large majority of developers I've been polling lately. And the number one reason I hear from developers is, it's just too hard. Well, historically speaking, I'd agree. It's been hard to do real-time properly, but not anymore. It's actually becoming pretty easy. So what's changed, you ask? Well, there's a new class of real-time databases and services available to us that largely solve the challenges of building real-time features. And in this module, we'll look at one of the leading open-source real-time databases, RethinkDB. We're going to learn about RethinkDB by working through a simple example. So let me set the stage for you. Imagine for a moment that you work at a software company that produces games, and you've been tasked with building a real-time leaderboard for one of your more popular games. Your objective will be to figure out a way to get the top 100 player scores and display them in real time to hundreds or potentially thousands of players. One solution that a lot of developers naturally gravitate towards is having the client periodically query for the top 100 players and update the view. We'll call this the polling option. This might seem like a reasonable first attempt, so let's solve our problem using the polling option, then we'll take a look at the pros and cons of our solution. To keep things simple, for now, we'll create an app that just displays the leaderboard in the console. Okay, so using Sublime Text, we'll create a file called leaderboard.js. Now we'll go ahead and pull in a couple of Node.js packages. The RethinkDB dash module, which is a simple library for connecting to RethinkDB, and a local module called view, which has one function, render, which will display our results in a nice table in the console. Next, we'll create an instance of RethinkDB dash, passing in the database we wish to use, which connects us to the database so we can run queries. All right, let's create a function that will perform our leaderboard query and log the results to the console. We'll call the function polling updates. Now we need to query the database, and the language we'll use for that is called REQL, short for RethinkDB Query Language. REQL is embedded into JavaScript, so you don't have to concatenate strings or construct special JSON objects to query the database, as you would in most other databases. The queries are chainable, so you typically begin with a table and incrementally chain transformers to the end of the query using the dot operator. To query our database, we'll specify the table we wish to use, scoreboard, then we'll want to sort the results by calling the score field in descending order, which we can do by calling order by and passing in the field. In this case, the indexed score field. Now we'll limit our results to 100 records. Okay, that's how you write a basic query in REQL. So how do you get the results? Well, being a Node.js app, all our queries are happening asynchronously, so we have two options for handling the results: providing a callback function or using the promise that's returned by the query. I prefer promises, so that's what we'll use. So to get the results, we simply need to call the then function and pass in a function to handle the results. The function we'll pass should take one parameter, rows, which is an array of records returned by the query. Then we'll simply call view.render and pass in our rows array. Now let's call our function at the bottom of the file. Okay, one more thing. We need to have the query run every 2 seconds. Let's use the JavaScript setTimeout function to run our polling update function after a 2-second delay. So we'll call the setTimeout at the end of our polling updates function, passing in a function as the first parameter and the delay of 2000 milliseconds as the second parameter. Now the function we passed in as the first parameter will simply call the polling updates function, essentially starting a polling loop. Now let's go ahead and run this file using the node command. So as you can see, the view module renders new records in green for about half a second to highlight the newly rendered records. We see the records flashing green about every 2 seconds when the polling completes. Let's go ahead and insert a new record into our scoreboard table. I'll use RethinkDB's cool Data Explorer found in the web admin interface. Inserts are done by specifying the database name, the table name, and calling insert, passing in the object to save. And as you can see within the 2-second interval, the new score is displayed. Okay, this is pretty easy to handle. However, it has some flaws. It isn't truly real-time. It's approximately real-time, or within 2 seconds in our example, which may or may not be important to you. But the bigger flaw in this approach is that it isn't scalable. Let's do a quick estimate of the requests and the data transmitted using the polling option to give you a better sense of what I mean by unscalable. For discussion's sake, let's say your leaderboard has one change about every 5 minutes on average. Then let's say we have 1,000 people looking at the leaderboard on average, polling every 2 seconds, which means the query to the database would happen 30 times a minute per user, or 150 times over a 5-minute period. Extend that by 1,000 users and we have 150,000 requests. Ouch, that's a lot of requests, most of which result in no change. So let's consider how much data would be transmitted over that 5-minute period. Let's say that each record has about 100 bytes of data, a conservative number. Then extend that by the 100 records, and we end up with 10 kilobytes of data. Now, if we extend the 10 kilobytes of data times the 150,000 requests, we end up with 1.5 gigabytes of data. Wow, that's a lot of data. Okay, now let's consider the number of requests and the data transmitted under the best case scenario. In the best case scenario, we wouldn't have any requests. The clients would just be notified when a change occurs. So 1,000 notifications, or one for each user. And the clients wouldn't receive all 100 leaders, they would just receive the single change, or 100 bytes. So the total data transmitted would be 100 bytes times the 1,000 clients, or 100 kilobytes. So the ratio of requests in the polling scenario to the minimum required requests is about 150 to 1. And the ratio of the data downloaded to the data needed is about 15,000 to 1. So although the polling solution is pretty easy to implement, because of its scalability issues, I think we can rule it out. So let's come up with a solution that is closer to the best case scenario, what we'll call the push option. In the past, creating a push solution would have required a pretty big engineering effort. There are a couple of options that come to mind. Creating a middleware that would grab the top 100, then having the middleware periodically query for the new top 100, calculating a diff, and then figuring out who needs the diff and sending it to them. A slightly better option would be to add a coordinator that would be notified when updates to the scoreboard occur, then the coordinator could push the updates out to the client. Both of these options are workable, but the problem is it's challenging to design and it's complex to maintain. At this point, many developers decide it's just too much work and not worth the effort. But fortunately, RethinkDB has a feature called changefeeds that can handle this complexity for us. Here's how changefeeds work. You write a query, like we did earlier, then you call changes, which makes the query a change feed. Executing this change feed will initially show the top 100 players from the game board. But here's what's different. The change feed provides a cursor that blocks, waiting for any new changes in the database, and then it streams those changes as they occur. So let's implement our change feed-based solution. We'll create a new function called push updates. Then we'll copy the query that we wrote for the polling updates function. Then we'll add a call to changes at the end. As I mentioned a moment ago, the result that's returned by the change feed isn't an array, it's a cursor that we can iterate over by calling the each function and passing in a callback function, which gets passed an error and a record parameter. Now we just need to call view.render in the each function, which will send the initial dataset to our view and any subsequent changes to our view as well. Now let's run our application, and as you can see, all the records are initially green, indicating they're new. Then after 1/2 second, they change to white. But in contrast to the polling option, we don't see them turn green every 2 seconds. Let's insert a new record, and as you can see, the change is streamed to the console in real time. Okay, well now you should have a little better understanding of the real-time problem space, and hopefully you can see the benefits offered by the real-time features in RethinkDB. I've included a link where you can find out more information about change feeds,